I'm going to be honest, this day kind of kicked my ass, and I'm really surprised because this day, like this year has been really hard. This would be like comparable to like maybe like a day 15 or 16 from a prior year, which is pretty surprising, but I'm kind of excited to see what the rest of the year kind of entails. So for this question, um, I'm going to kind of just get straight into it, assuming you've already kind of toyed with the question because it is going to take a while. So, with the first question, we're basically seeing stuff where we have these little mappings, where this is basically saying 98 up till 98 plus 2, non-inclusive, on that upper bound, gets mapped to 50 to 52, non-inclusive, and so forth. And we're basically just passing these numbers in through these mappings. So, for example, the 79 here would first go through this mapping because it fits in this 50 to 50 plus 48 range, yada yada. And I think you can see that in the example. Um, like I think you see here, when you pass in like 79, it ends up passing to 81 and so forth. But yeah, I'm gonna go ahead and assume just for the sake of time that you've read through and understood the question. Go through the example if you haven't. So let's go ahead and start programming this. So I'm gonna open up my VS Code and I'm actually gonna open up my solution on the side just because I don't want to waste time rederiving everything. It's gonna take a while. So all right, so first things first, let's go ahead and read the input. So the input that we're seeing is going to be something like this, where we have our first line of seeds, and then the rest of these all follow the same format. And we don't actually need to know these words, like these names, so we can just drop those out. So what I'm going to do is I'm going to call input.split. The little trick is I can split it on two new line characters instead of just calling split lines. And if I go ahead and print this out, and I run this on the test case, you can see we basically get it like this, where it chunks up based on those two little line spaces, which is exactly what we want. And then I'm going to do a new little trick I'm going to show, which is I'm going to basically unpack several things into an iterable object. A lot of big words, don't worry about it. Let me show you with an example. So if I do, first of all, I want to have a line for the seeds, and I want to save the rest of these into a list. So I'll do um, maps or map inputs is equal to this. If I just try doing this, Python's going to complain because it's trying to unpack all of this into these two variables, except I have like 8 things because there's 7 rules. So if I put a star behind one of my arguments, what it tells Python, and if I go ahead and actually print these out also, oh, here. What this tells Python is, hey, go ahead and just fill up everything else into this variable. And so, oh, printed out all of this stuff. Oh, sorry, here. What I now have is seeds. The first thing gets stored into this. Everything else gets unpacked into this list object and map inputs. So now that's all great and dandy. From this, we have to go ahead and parse these into some kind of actual like usable data. So first of all, we can change the seeds into just the integers. And the way we can do that is, first of all, if I do print seeds.split, if I do this, we can see that I get all of these nice little things as numbers and then the first string. So I'm just going to drop that off by doing list slicing here. And by this, now we have all of these, but they're still strings. So a nice little trick that you're going to see me be doing a good amount is something called map. Map is something that scared me a lot when I first started programming because I never really got the point of it. But what this does is it basically calls my first argument, so whatever this is, on everything in the second object. So I'm going to call int on everything in here. And then one little caveat is this returns me a map object. And so you actually have to turn that into something else like a list or a tuple. But now what you can see is what I did is I called int on every single thing in this object, and then now it's stored into a list. And now we have all of these working as integers, which is what we want. So I'm going to save this. I'm just going to overwrite the seeds variable with this. So now if you can see what we have before this line is seeds, and what we have after the line is this. So we turn this line into a list of integers. Perfect. So now we want to actually read these map inputs in a way that matter. And so for this, we're going to go ahead and do a little object-oriented solution. So I'm going to create a new class, so class map, and I'm using a capital M here. If I did a lowercase m, it would overwrite this thing here, and I can show that. So if I run this, should be no problems. If I run this, ooh, it doesn't like it because I'm overwriting it. So capital M, anyway, good practice for classes. But now let's go ahead and create a constructor. So we're going to go ahead and take in whatever the map string is, or we'll call say consistent. So let me change these down here. So map strings. So now from this, so we have something like this, and we want to parse it into some useful information like these. So let's go ahead and create a variable called rules. And this is going to store all the little mapping rules that we have in the object itself. So now for each line in the map string, and we split it by lines, and we want to drop off this first line. So we're going to use the list slicing again. And then now we have each of our lines. So if I print out my L like this, and just for demonstration's sake, I'm going to call this on the first kind of map string that we get. Oh, map strings there. So now you can see we're printing out every line one by one, and we're printing out first this line, and then we're printing out this line, which is what we want. So now in here, let's go ahead and actually just read these into numbers. So I can do dest, source, and then size. So this is all kind of defined in the question. So I'm going to get these from, again, doing my little trusty map int onto l.split. So L here, L is going to be something like 50, 98, 2. This is the first line in the example right here. And then when we split it, so l.split is going to be equal to a list of 50, 98, and then 2 like this. And then when I call map int on this, I'm basically calling int like this. Calling it here. Then I'm calling it here. And I'm calling it like here, so forth. And then finally we get some iterable object, a map object, that we can unpack into these variables, which is what we want. So now from these, I can go ahead and add these to my rules. So self.rules.append, and we'll append dest, source, size. Perfect. And now if I want to just go ahead and see like a little representation of this, if I print out the rules like this, we see all of our data in a nice little list so we can process this. Perfect. And then finally, the last thing we're going to add is a function, just a little helper function, to convert some input number through our map set of rules. So the way we're going to do this is for the source size in self.rules. So we're going to go through each rule and see if we actually fit inside one of those rules. So if we are within the input, so the source, and here source plus size, and then let me explain this line in a second. I'm actually just going to write this code down, and then I'll explain it. All right, so here, so if we look at this example, a nice little, like a good way of approaching these questions is just take an example by one by one and then extrapolate. So here, if our input is 98, and this is saying we can map from 98 to 50 and do this for the next two numbers. So 98 should get mapped, and here I can back this up by showing this. Here. So the source range starts here. And since it has a range length of 2, we are only containing 98 and 99. So if I have 98, if I add the 2 to it, I get 100. And if I notice, this number is less than 100, but not less than equal to. But the starting number is less than or equal to. Basically like inclusive versus non-inclusive for the ranges. So that's why here, if the source is 98, then 98 does fit this condition. Size is 2, so if I see 99, it also does fit this condition, because this would be 100, but 100 does not. And so that lines up with the project specification. And then now this line. So if I'm trying to map, for example, just 98, like I pass in 98 and I try to follow this rule, what should happen is it goes to 50. And the way we can do this is we can subtract the source, in this case would be 98, and we add the destination to it, so 50. And the whole reason why is, like, since this is like a linear kind of shift, like if I add 1 to my input, it gets added 1 to this output. I'm basically just like subtracting this to get me back to like a constant value of 0, and then adding this to get to this constant value of whatever the destination is. And then if I have 1 more than this, it's just 1 more through that entire kind of formula. If it's still kind of confusing to you, just take a couple like examples by hand and try running those through. All right, so now what this is doing is when I pass in an input, it'll go through each rule and see if it fits it. If it does, it returns its new value. And if it doesn't, it says here numbers that aren't mapped just are the exact same number. So we'll just go ahead here. If we didn't match on any other rule and return out, finally just return whatever we got for our input. Cool. So now we have our map kind of class done. And then here, what the question wants us to do is find the lowest location number. So to find this, we basically go through all of these maps like in order. So the way we can do this is we'll create a little helper function. So we'll do def get location, and it'll take in some seed and whatever maps we have. From this, for each map we have, we want to convert our seed. So m.convert seed. And we're overriding this variable just because we don't really need it for anything else. And we finally return it. So what this is doing is it's going through every map that we get, converting it, and then passing it into the next map. So like, for example, here, we would take our seed of whatever, pass into this map, whatever soil we get, pass it into this map, whatever fertilizer, so forth, until we finally get our location and we just return that. All right, so now that we have all of these, let's go ahead and define our maps also. So maps is going to be equal to, and I'll use a list comprehension this time, map on map string for map string in map strings. Sorry about my variable naming convention. It's a flaw that I have. And if I print this out, we should just see a ton of map objects like this. Perfect. And once again, I could have done this with a list comprehension by doing this, but it's a little bit less readable. I believe this is it. Yeah, see how it's the exact same? It's a little bit less readable, but I'm basically just calling the map. I'm calling map on every object in here, which calls a constructor, and then turning into a list. But let's just go ahead and use the list comprehension for now. All right. So now that we have all of our maps, let's go ahead and let's make a list of our locations. And so our location should be get location for each seed for seed in seeds. And then this function also should take in our maps. If I print out locations, we can see here, these are the locations that we get. And then, so remember these, 81, ooh, something went wrong. All right, so I'm pretty stupid. I spent a while trying to figure out what my bug was, and the bug is just I can't read properly. But here, so if I print out the locations, if I look at the proper place in the code, we can see the locations are 82, 43, 86, 35. 82, 43, 86, 35. Perfect. So now the answer that they want is the lowest one. So let's go ahead and just return that as our lowest. So return the min of locations. And then I'll get rid of these prints. Oh, sorry. That's me submitting. But here. Now that works. If I go ahead and run on my input, I can see 289 yada yada, 289 yada yada. Perfect. All right, now for part 2. Part 2 is going to be a huge pain, and so let me just take a second to explain this conceptually. If you try to just brute force and like convert your ranges into just individual numbers, you end up with like millions, or I think maybe even more of numbers, because if I look at my input, these are some pretty big numbers. And so if you try to run each one of those, your computer will just kill itself, or it'll take like 10, 20, 30 minutes to run. And that's not really what you want. And so usually a nice thing about AOC is every day is intended to be able to run in I think less than 10 seconds on an old computer, something like that. And so there is a nice solution. And in our case, the solution is doing some fancy math with ranges. So instead of calculating every single number individually, we're going to do math on the entire range. Because for example, if I look at this earlier kind of case, if I have the numbers 50 through 55, I shouldn't have to compute each one of them individually. I can just make the range 50 to 55 to 52 to 57 and so forth. But the math does get a little bit annoying. So for our sake, what we're going to do is we're going to create a little range class. So class range, and we're going to take a lower and an upper. And we'll just save those to variables. Oh, I'm being stupid, sorry. All right, so with this range class, and we'll have a little bit of a helper of this, and then here. All right. So, and then also just so this video is not like 2 hours long, I'm going to be copying and pasting code from my other monitor where I do have my working solution, but I will try to explain it as I go. All right, so the first function that we're going to want to use is an intersection. And so for our range, if we have something like, I'm going to kind of denote ranges like this. If we have these two little ranges, we want to be able to find the intersection of them because our rules are essentially ranges ranging from source to source plus size, and they map to some desc plus size, like a range like that. And so we want to be able to find, given some range, because they're not always going to like perfectly line up. If I get a range like this, and this is my rule, I want to basically apply the rule just on this part of the range. So then that all gets changed, and then I just continue with this. So for that, we need an intersection. So with this, we're going to take in another range as our object, and I can give it a type annotation like this, so that it kind of just gives me a nice little syntax highlighting and hints. What we're going to do is we're going to create a new temp range, and I'm going to write this line and explain this. Actually, I'm just going to copy it, but I'll explain this in a second. Here. All right, so what this is doing, and this is probably best illustrated with a little diagram. So if I have something like this, my intersection of this range is defined as, in this case, the biggest lower point and the smallest upper point. And also to specify all of these ranges are inclusive on the left side and not inclusive on the right side. So it's like a Python range, but basically, like all you need to know is it's kind of like the math syntax like this, where this is saying 4 is included, but 10 is not. So our upper is not included. But here, so if I have these two ranges like this, I want to intersect them, then this works out. And you can show, like you can see it because the intersection becomes the lower, the maximum lower, which is this one, all the way up to the lowest upper bound, which is perfect. And then if I also want to prove this for the other case where it's like this, then again, the biggest lower bound is this one, and the smallest upper bound is that one. So that's what we get. And then other cases, if they don't intersect, we end up with this, the range starting here and ending here, which doesn't make sense, and we'll take care of that with this line here. Nice little segue. All right. Here, what we're doing is if our range makes sense because our lower value is less than our upper value, we return it. Otherwise, we'll return none. None will be your kind of like placeholder for an empty range. So now that's taken care of. In the other case also, in the other case like this, same thing. Our maximum from our lower is here. Our minimum from our upper is down here. Doesn't make sense, doesn't hit this criteria, so we return none. And the other cases we have to worry about, and these cases are symmetric. So like if it works for this one, we can kind of just swap them arbitrarily and it's fine. But so here, now the upper lower one is this one, and the lower upper one is this one. And this is our intersection. So hopefully this kind of convinces you that this works, but this is how we're going to get our intersection. And then now the other thing we need, and I'm just going to go through and like crank out this class, and then later I can kind of explain why we did this. But now we're going to need a subtraction. And I can kind of explain why we need this now. If it's not a perfect explanation, don't worry about it too much. I'll try to explain it later as we get to it. But here, if this is, for example, the rule that we have, so it's saying all of these numbers are mapped in some range, and then this is currently the range we're working with, I want to apply the rule on just the intersected parts. And then I want to be able to keep the rest of the parts separate and then keep processing that. Like, for example, maybe this makes more sense. If I have like this, where I only have like the ranges kind of defined from like 50 onwards, if I'm doing something and my input range is 48 to 51 inclusive, then I want 48 and 49 to get basically split up from these two, which do follow some fancy rule. And the way I can do that is if I have something like this, I take my intersection and I can subtract it from my original range to basically get left with everything else. So the way we're going to do this is we're going to do this by cases. So first of all, we're going to go ahead and get our intersection. So like this, we're going to call our own intersection function with ourselves, and then we pass in the other class. Now, if the intersection is none, which is returned here, that means these two ranges don't intersect at all. So our subtraction should do nothing, because if I'm trying to subtract these values from this range, I just do nothing. So we return range self.lower, self.upper. So the design, there's two design choices that I'm kind of making here in this. You could ask me like why I'm not just doing like return self or something like that, or return nothing. But first of all, I'm returning a new range object just because I don't want this to be modified. If I return self, maybe later in my code or somewhere else, if it modifies every instance of this. So this way, I don't have to worry about modifying this. But second of all, why am I returning a list? Well, if I'm trying to take the subtraction of something like this, I should end up with a range like this. And I get two separate ranges here because each of my ranges is only one contiguous set of numbers. So instead, for my subtraction, I'm going to return a list so that I can handle the case of I need to have two separate ranges as my output. So I just want to keep everything consistent by returning lists. All right, so this is the case if there's no intersection. So let me kind of make this diagram like this. Now, another case is what happens if I'm returning basically this. What happens if my intersection is just everything that I currently have? Then what I want to do is I want to just return an empty list because I'm basically wiping out everything. Because if I do self minus this intersection, I end up with just nothing left. And the way I'm checking this is if basically the lower and uppers are the same for both of them, it's the same range. Good enough for me. All right, now what happens in this case? If I have a case where, so first of all, my intersection, at least one of the bounds should be on either the leftmost side or the rightmost side, or it's going to be in the middle. Like it's going to be either that, this, or that. And the whole reason why is there's no chance my intersection is outside of my original self range because then it wouldn't be an intersection. But so now, if the lower bounds are the same, then to get my new range, it's just going to be all. So first of all, keep in mind, the upper value isn't included. So I can just create a range from that upper value, but this time including it since it's the lower bound, all the way up to my original upper bound. So this is basically writing down just this area. Cool. Now, what about if I have the other case? So if I have this case where it's on the upper side of the bound and I check it like this, then I just return the lower bound of my original thing all the way up to my original, or my intersection's lower bound. Perfect. And then finally, the only ugly case, which is this one. If my intersection is somewhere in the middle, I need to return two different ranges. And so first, I'm going to return a range from my original lower all the way up to the intersection's lower, and then another range from, so this is a little bit more, all the way from the intersection's upper value to my upper value. And so these basically give me all of my kind of subtracted ranges. And so this is what we're going to use to be able to like split up ranges when we need to. And then finally, a little quality of life thing is going to be an add, where I'm going to be able to just offset, give me a new range, like shifted by some offset. Return range, self.lower plus offset, self.upper plus offset. That's it. And then that's our entire range class. That is not a good idea. Oh, it's because I guess I just can't define it inside of here. But, all right. Everything compiles, everything's happy. Oh, flag. Here. Cool. All right, so this is our entire range class. I know this is complicated and it doesn't make sense why I'm doing this, but please bear with me. I think this is the easiest way for me to do this. And at the end of the day, that's kind of all I'm here for. I'm sorry. But hopefully it makes sense in a bit. All right, so now this is where things get a little bit dicey, and I apologize. I'm not going to be able to explain this that well. But what we're going to do is we're going to have a set of our ranges. So first of all, let's just crank that out of the way. So for part two, our ranges, let's go ahead and the way they specified it is these are actually pairs, where this is basically saying the start of the range, and this is saying how big the range is. Start of the range, how big the range is for our seeds. So to parse that out, we'll do for I in range len seeds, and then I'm going to make this jump by 2. So if I do this, I can give a range 3 arguments, where the first one here, so we have a start, a stop, and a step. So I'm telling it to go all the way from 0 up to the size of the list and step by 2 each time. If I print out I, you can see it's 0, 2, and this corresponds to 0, 2. All right, so now if I print out range, and I print from my seeds at seeds I plus seeds I plus 1. And the whole reason I'm doing this is because my range should go from 79 to 79 plus 14. If I print out all of these, yay, these are my ranges. This is what I want. So now I want to process these ranges somehow, where I take the range, like the first range, and then feed it into this, and then see like I get some ranges on my soil. Then I take my soil ranges, I feed it into these rules, and I get some ranges on my fertilizer. And I keep doing that until I finally end up with some ranges on my location. And then, since I want to choose the lowest one, I just save the lowest one out of that range. So I'm going to do this with a little bit of like a weird little recursive solution. And for this, bear with me, I'm going to create a new class. So this is going to be a solver class just because I want to have some shared variables and I don't like using globals. So this is going to take in my maps and it's going to have an answer variable. And this should be the smallest, location that we get. So I'm going to start off with the biggest number I can think of, which is infinity. All right. And so now I'm going to create a function called propagate. And what this should do is, and let me just add some annotations. It should take in a range and it should take in some layer, and it should basically try to fit this range into every single rule from the maps for that layer. So if layer is 0, try to fit this range into as many rules as you can, and then keep processing those. And so hopefully after you see the code, it'll make a little bit more sense. So take some time to go through it. But here. So first things off the bat for writing recursion is our last case. So if layer is equal to len of self.maps, and keep in mind this means it would be out of bounds if I tried indexing into it like this. But if this is the case, this means we basically finish passing it through every single map and we end up with some location. Then we have some range, our answer, so the range, the only potential answer from this range would be the lowest value, because that's what we're looking for. So I will just set my answer to whichever one's better, the current answer or range.lower. So this is the case of we already are at the last layer and we've turned everything into a location and we just end up with the ranges. And then if that's the case, let's just go ahead and return out. All right, so now otherwise, this means that we're still needing to pass it through some map. So for each dest source size in that maps at each layer. Here. So what this line is doing is, for example, if I'm passing in the first call, where I'm calling it on layer 0, I'm looking at all of the rules for, what is it? Seed to soil. And then I'm going to iterate through all of these. I'm going to first turn this into a range so that I can call it with my other things. So it'll be map range is equal to range starting at source and ending at source plus size. Now let's see what our intersection is. So my intersection between range is called this. And then when I intersect it with map underscore r, then we end up with our intersection. If we do have some intersection, so if it's not none, then that means we can map at least part of our range to the new values. So from this, let's go ahead and do self.propagate inst to add this source, and let me explain this in a second. All right, so here our intersection is basically meaning that part of the rule matches the range that we're currently processing. So let me go ahead and try passing this on to the next layer. So for example, if I'm solving and I have the range 48 through 51, 50 through 51 does match the rule. So let me just go ahead and create a new range just containing these and then pass this into soil to fertilizer. Like just let that part keep continuing and eventually we'll deal with the leftovers. So that's what's happening here. The intersection, so the part of the rule that does match, we're going to first of all shift it up by the destination minus source. That's what we basically did here, dest minus source plus in. So this basically adds the rule to whatever the range is, and then we just keep calling it. Cool. So now we need to make sure not to process this part again. So let's get the subtraction of these ranges. This is going to be your subtraction. If after we subtract it, we end up with nothing, which is this case, then that means the rule that we're currently processing is all handled. This already handled all of it. Then we just return because we're done. Otherwise, we at least have something in our list. So we'll keep processing the first part. If we have more than one thing, so in this case, then we also need to process this part. And we'll do that by calling self.propagate sub1 at our current layer. So basically, hey, just go ahead and keep processing, like process this other part again at my current layer, just to make sure I didn't miss anything on that section. And then finally, if all of this has ran, like we get to here, if we get to here and we still haven't returned out from this, meaning we still have something left over, go ahead and pass that to the next layer. And this is basically following, where's the rule? This one. This follows this rule, where if it hasn't been mapped, just go ahead and continue with the same numbers. All right. So now, what I'm going to do is instead of just printing this, well, I'm sorry, my voice is like gone. I'm going to go ahead and create a solver. And then instead of just printing these ranges, I'm going to do p2 solver.propagate. And I'm going to propagate this at the first layer. And then once I do this for all of my ranges, I should be able to just see my answer. Oh. Oh my god, I'm gonna die young. All right, I've gone ahead and got a something to drink, and I sat here for like 5 minutes trying to chase down some really stupid bugs. So, well, these are just mistakes on my end. First of all, this is P2. So we call it on the object we call propagate. I also found out I don't know how to spell propagate, so I fixed that. But also, this sub here should be subtract. That's my bad. All right. But finally, if I call all of this, I get 46. And if I look at the answer, 46 is the lowest location. And the more important part is if I run it on my input, in 24 milliseconds, I get this 605 ends with 880. 605 ends with 880. Finally, that day is done. Let me just go ahead and run through again kind of the logic here. I think this is the big meat of it. What this is basically doing is taking some range. So if I have some range at some layer, so for example, if I have a range of fertilizers, so we'll say 10 to 15, okay? So when we go through this, this is not the case. This is if it's at the end. But other than that, we go through each rule, and then if it matches part of the rule, we chunk off that part of the input and then send that to the next layer. And then we keep going until we're either out of input or we're out of rules. And so for example here, if we have the range, I'll just do 0 through 10. If I have 0 through 10, I go through this rule, nothing happens. This rule, nothing happens. Oh, this rule does match the first 7, so I pass off 0, like I create basically a range 0 through 7, pass it through this rule, send it off to water to light. And then I end up with the range of 7 through 10. And then I see this rule, and I match that off, send it off here, and so forth. That's basically the whole point of this function here. And I think the rest of this stuff here is just like math with sets. So this is fairly well documented online if you Google it. But overall, this day is pretty confusing, and also my explanation is not the greatest. This code is going to be on the GitHub. Please let me know if you have any questions. I'll do my best to answer comments. But yeah, thank you. Goodbye.